Hi, everybody, and welcome back to another installment of the EBI seminar series on science communications. I'm joined today by Professor Don Moore. Don Moore is a professor in the Haas School of Business at UC Berkeley, and his research interests include overconfidence and decision-making. He is also the professor of management of organizations at the More Accuracy Lab, which is committed to testing the replicability of published scientific work. How are you doing today, Don?
I'm great. It's wonderful to be with you, Logan.
Great. Okay, so we're going to jump in with our first question, which is the More Accuracy Lab claims that it contributes to the vanguard of open science. What is the meaning of open science?
The term open science refers to a suite of activities that basically seek to make the scientific process more open and transparent to readers, reviewers, and other scientists. So it begins at the very start of a research project when you're planning your sample size, your design, your statistical analyses, and documenting those details in a pre-registration that gets posted publicly that anyone who's interested in understanding the research better can look up and read about. Then, as you get closer to running the study, you're developing materials. In my case, I'm often using surveys to collect data from human participants. So that means I take my survey instrument, whatever that is, and I post it publicly online so that anyone who wants to understand what I did can go look at the survey and see it for themselves. Then when the data come in, I take the raw data file as downloaded and post that publicly so that anyone can see exactly how the data came in, warts and all. Then when I do my work cleaning the data and analyzing the data, conducting the planned statistical analyses, I take that code and also post it publicly so that anyone who's curious to understand more of how I made choices about inclusion or exclusion criteria or exactly how I specified my statistical tests, they can go check that all out for themselves.
Okay, gotcha. So why is it important to have replicable science?
If it ain't replicable, it ain't science. One of the most fundamental bedrock principles of science is that the results should not be idiosyncratic to the identity of the scientist conducting the study, that others have to be able to replicate it if they follow the same formula that the original researchers followed. And so replicability is at the very heart of what makes science reliable, true, and scientific.
So when you're going about replicating science, what steps do you take to do so?
Crucial is research planning, which I was just describing. So even if the original study wasn't pre-registered when we're replicating it, we try to be deliberate about all the steps involved and complete a pre-registration where we highlight all the key choices in design and sample size selection and things like that. We'll also usually try to contact the original authors to verify that they agree that our plan qualifies as a close enough replication of their original procedures and materials that it represents a fair test of the replicability of the claims that they make.
Okay, and getting more at the details here, what are some of the inspirations that determine which projects you take on to replicate?
I would identify three major sources of inspiration for the replications that I've undertaken in my work and with my colleagues in the accuracy lab. The first source of inspiration is Journal Club. We hold a weekly Journal Club here at the Haas School. Each week, one of the faculty members who's involved in Journal Club picks an article, and then we meet on Friday to discuss the article. Sometimes those discussions make us want to figure out if we can replicate the study for ourselves. So I have a couple papers where we take on the assignment to replicate papers that we read in Journal Club, and sometimes we learn interesting things in the process. Right now, we have a paper under review that's just a letter to the original journal that published the paper that we read back in December in Journal Club. The second source of inspiration is the replicability class that I've taught a few times with my friend and colleague Leif Nelson. It's a PhD level class where we try to share with young scholars some of the tools methods and practices that constitute open science. And as a part of that class, we conduct replications. Each time we try to define a particular body of literature, some set of related findings, and then randomly select from that set studies that we can feasibly replicate in the course of a semester. And then the students put into practice all the things that they learned in the class. And then we gather those results up at the end and write them up and send them off to be published. The first time we taught this class in 2019, we collaborated on replicating results from a literature known as the psychology of scarcity that examines the ways in which being poor or not having enough material resources can affect people's thinking and decision-making. The second time we taught the class in 2021, we looked at the psychological licensing literature. This literature documents ways in which sometimes being good can license us to be bad, where you engage in some virtuous behavior, and then it can sometimes increase the probability of behaving selfishly or less ethically in a subsequent task. And then when we taught the class most recently, we selected studies from the research literature on construal level. Construal level is about the psychological differences in how people think about events that are near versus far, that are personally relevant versus not, that are specific versus abstract. So in each case, the results were interesting and enlightening. Replication was less than 100%, and the result tells us something about the durability and replicability of the claims in that literature. I missed the third inspiration. The third inspiration is self-replication. So there are times when I look back on a published claim of my own and wonder, is that going to hold up? The open science practices that should give us more faith in the truth of a scientific finding, these are relatively novel. So I have publications going back 20 years where I did not engage in the best scientific practice. In particular, I have studies that I've conducted in collaboration with people whose reputations have not fared all that well. Recently, a colleague of mine, Francesca Gino, has been accused of having engaged in fraud. And so I have some published papers with her where she was in control of the data, and I don't have the raw data files. And so I'm curious to know whether they replicate. So I'm in the process of trying to replicate my own published results.
Okay, very interesting. So with all these studies going on in the background of academia and stuff, it leads one to wonder, what are some of the ways that your findings can affect everyday people's lives?
Psychologists are interested in studying a lot of things that reveal fundamental insights into psychological operation that don't have direct application in people's lives. I'd say the most direct relevance of the replication work that I've done is in documenting which aspects of the literature are most reliable and true and which are less reliable and true, and thereby reducing the risk that researchers try to build on published claims that don't actually hold up, because that can produce a lot of wasted time and effort.
Okay, understandable. So do you worry at all that pointing out the flaws of science will lead people to distrust it more? And if so, what can be done to reinstate that trust?
I do worry quite a bit about the degree to which openness about imperfect rates of replication could lead people to distrust the reliability of scientific findings. And that concern is most pointed when I see instances when scientific controversies are exploited for partisan political ends. Nevertheless, I continue to believe that ultimately scientists and science will earn the most credibility for being open, honest, and self-critical. One of the things that gives science its distinctive claim for the truth is that science is self-correcting. but that depends on scientists correcting it. And attempting to replicate published claims is one of the most obvious ways that scientists can correct the published record.
So with that goal in mind, what do you think students hoping to become scientists can do in order to make sure that they are contributing to replicable and open science?
Yeah, people coming into the field now will be better prepared to contribute as scientists if they understand current best practices with regard to openness, reporting, and full disclosure. It is with that goal in mind that Leif Nelson and I have taught this open science and replicability class. There's a lot of useful information out there about the best ways to practice open science. And I will say what a profound inspiration it's been for me that this movement has really been led by young early career scholars setting a high bar and challenging the rest of the field to meet it.
Okay, perfect. What a great note to end on. So that does it for all of our questions. Thank you so much for joining us. Myself and everyone at
Thanks,
the
Logan.
EBI wish you the best of luck on all your future endeavors. Thank you so much.
Thank you.
Thank you for checking out the EBI seminar series on science communication. If you've enjoyed this video, please feel free to like and subscribe to our channel for more content on how science is communicated. Be sure to follow along for future installments or check out our previous series and explore our social media, which are all linked in the description below. Thanks for watching and see you next time.